Good morning. Today I will be giving a presentation on AES, that is Advanced Encryption Standard. Now, our first question comes is, what is AES? AES was a technique developed in order to convert plain text to ciphertext, and it was developed by NIST. First point that comes is that AES is a symmetric block cipher. Symmetric block cipher refers to as that both the sender as well as receiver both will get the same key. Now key plays a very important crucial role in all these encryption technique. It is also used to transform plain text at every step. Now, what are the points to remember? First, that AES is a block cipher. Block cipher refers to as it doesn't do bit by bit manipulation. It does block by block manipulation. It will take a block of like 128 bits and modify it after in every step. Then the key size can be 128 bits, 192 bits and 256 bits. Means it varies on the type of AES you are using. It could be of 128 bits, 192 bits and 256 bits. After this, the encrypted data we get, it is also in the block of 128 bits. Then we map it into the matrix of like 128 bits and we pass it to the this thing wherever we have to store the ciphertext. Now the third point says this block is depicted as a 4:4 matrix of bytes. Now whatever plain text we get, we convert it into an input state, and that input state is a 4:4 matrix. Now this input state becomes the input for every step. This state is actually modified at every stages of this technique. What we do, first we take the state matrix, we make it go through initial transformation. In initial transformation, we add input state with round zero. Here addition doesn't mean normal addition of mathematics. Here we do XOR bitwise operation between each element of both the operands. And then we get a state matrix. Now this state matrix is input to round 1. Round 1 until round n. We have 4 transformations in each round, and then at the end we have round n, which has 3 transformations. Now this n depends on the number of bits a key has. Like if it's 128 bits, we'll have 10 rounds. If it's 192 bits, we'll have 12, and if it's 256 bits, we'll have 14 rounds. After this, we can say that the final state is copied to an output matrix. Now whatever state we get here, it is copied into a matrix, and it is just sent to wherever it has to be stored. The last point says that the key here, the key which are getting in m bytes, that is also converted into a square matrix in order to move further with the manipulations. Now here we'll just go in detail with what all steps are there in each round. First we do the add round key. This is initial transformation we just saw before. We got a key from here and we added it with the plain text. Here the key ranges from w of 0 of w from w0 to w3. This is the key we got from the sender. Now our first step is to substitute bytes. Each element of the matrix, we'll map it using SBox and we'll create a new matrix. New state matrix will be created. I'll explain this in the further slide. Then the second step is shifting rows. Every row of the state matrix will be shifted. If it's 0th row, we'll not shift it. If it's first row, we'll shift it one time in the left direction. If it's second row, we'll shift it 2 times in the left direction, and if it's third row, we'll shift it 3 times in the left direction. After this, we'll get a new state matrix that will go into mixed column step. In mixed column, we'll multiply this column. In this step, we'll multiply the state matrix with a predefined matrix, which we'll see in further slides. And then we have a last step, which is add round key. Here also we'll get a round key from the expanded key, and then we'll just do bitwise XOR operation. Now this is all the detailed step. Here what we did, here we mapped each element using Xbox and created a new state matrix. Here we just shifted it. We shifted last row 3 bits to the left, second row 2 bits to the left, first row first 1 bit to the left. Here we multiplied it with the predefined matrix, and here we just added the round key. We did XOR operation. After this comes the creation of first round key. What we do in this is, since we got this key, this is the key. First we divide the key, like W of 0, W of 1, W of 2, W of 3. We'll divide it into 4 parts. Now from W0 to W3 we'll use an initial transformation, which we just saw before. After this we'll try to find of G of W3. In G of W3, what we'll do, we'll first circularly byte left shift of W3. Means we'll make 20 as the first element, 46 as second, 75 as third, and 67 as the last. Then we'll do byte substitution. Byte substitution is the same as we did earlier. We'll map 20 using Xbox as B7. So 20 is converted to B7, 46 is converted to 5A, and so on. After this, we will add a round constant, that is 01 to 01, 00, and so on. So if we add B7 to 01, we'll get B6, and after that it remains same because the constant is 0. In order to find W4, we will do XOR operation between W0 and G of W3. For finding W5, we'll do XOR operation between W4 and W1. We'll do this until we get all the keys, like till round 10 we need like W40. So till then we'll do the XOR operation in order to get keys at every step. After this, if we have to decode decode the ciphertext, we just have to do the reverse operation we did until now in order to get the plain text from this. Thank you.